This topic is electron affinity. Again, this word has two words in it. Or actually, there are two words here. Electron. What is an electron? It's negative, right? In an atom. It's a particle, or it's constituent of an atom with a negative charge. Affinity. Love for something, right? How does this love come about? If you were to look at an atom, it has a nucleus, right? Let me just draw a simple atom, a hydrogen atom, okay, with just one electron and one proton. Let me have proton with another color. Okay, so now proton is positively charged, right? Electron is negative. Now this positive and negative will be attracted towards each other, and this is what brings about this love for the electron. Now, what exactly is electron affinity? Is basically if you have an electron here, it's going to be pulled and incorporated into this energy level here, and this is now the electron affinity which we are talking about. Electron affinity, by definition, affinity is the enthalpy change that occurs when 1 mole, or actually before we go into 1 mole, when one atom, but this has to be a gaseous, when one gaseous atom gains 1 electron to form 1 negatively charged gaseous ion, right? Now, if you write it in equation form, assuming I have an atom, say A, okay, it's in gas form, I'm going to add an electron to it. Resultant will be A negative, still in gaseous form, right? And this is what we are referring to, this enthalpy change, as negative or positive. Now let's see how this enthalpy change will be positive or negative. Now, when we talk about electron affinity, imagine this scenario here. Let's take this same atom. It has a proton, right? It has only one proton, and now it has this electron and this electron, okay? Now it has only one proton, but it has now 2 electrons. Do you think now the positive attraction is more than, see, now there are terms here which we'll discuss later, but do you think they will be more positive or more negative? Yeah, they will be more negative. So now that means at first, when it was gaining at first, there was a higher attraction of this electron, but after there will be a lower attraction of this electron, because now the incoming electron which is going to be attached onto this atom, it's going to be repelled by these negative electrons which are already there in the energy levels. So now when we're adding first time, which is also known as first electron affinity, it is going to be exothermic, or heat will be given out. However, second electron affinity will be endothermic. Why do you think it will be endothermic? Yes, because it is the electron incoming will be facing the repulsion from the electrons already in the energy level. So you have to supply energy in form of heat to overcome this repulsion. So it will be endothermic, and therefore heat will be absorbed. And this one will be positive. So this one's delta H will be positive, it will be negative. So now therefore the perfect definition for electron affinity, which I'm going to write now considering these two scenarios, is, just give me a second to choose the color. Okay, so therefore electron affinity is the enthalpy change that occurs when an atom, when a gaseous atom or a gaseous ion, regardless it's positive or negatively charged, it has to be a gaseous ion, gains one electron to form one gaseous ion. Okay, this is now going to be a definition considering both the first electron affinity and second electron affinity. However, if you had to write the one for first electron affinity, I can also write that one for you. Okay, so first electron affinity is the enthalpy change that occurs when one gaseous atom gains one electron to form one gaseous, one negatively, and this is actually uninegatively, so let me just write very well. Enthalpy change to form one uninegatively charged gaseous ion. If I write it in equation form, basically A, gas, any atom, we're adding electron, we're going to form A minus gaseous, delta H here, actually this is not the enthalpy change, but this is the heat given out. So delta H here will be negative, in bracket exothermic. Now let's go and talk about second electron affinity. Second electron affinity let's use red. Second electron affinity is the heat required, because you are going to be supplying it to the reaction to add the electron, right? So is heat required to add one electron to uninegatively charged gaseous ion to form one bi-negatively charged gaseous ion. So if I represent this one in equation form, it will be A gas plus electron, we're going to form. So here the enthalpy change will be positive, also endothermic. Okay, now we have talked about all the stuff of definition and basic concept. Now let's talk about what really governs the addition of electrons into the energy level, right? So let's continue. Okay, so factors affecting electron affinity. Now we have an atom. It has protons, right, in the nucleus. Now we have electrons here. Now if we are going to see is that protons, they'll be attracting, right, and electrons will repel the incoming electron. So here comes two terms. There is something called nuclear charge, basically attraction, and screening effect, basically repulsion. There will always be a net which is effective nuclear charge. Now this will be the net result of these two. If the attraction is more than repulsion, you will have a attraction. If repulsion is more than attraction, you will have a repulsion here. Now, therefore, what are some of the factors which affect it? Number one, nuclear charge. Number two, screening effect. Also, just imagine if the atom is really big. If I continue adding energy levels here, that means the electrons, the outermost electrons, are far away from the nucleus of the atom, right? So one of the things also can affect is atomic radius. So these are some of the factors which affect the electron affinity. So down the group, what happens is that down the group the atoms become bigger and bigger, isn't it? We continue adding shells. Now that means down the group the tendency of the atom to attract the electron towards itself will decrease, isn't it? So the tendency to attract the electron will decrease, right? Therefore, what will happen is electron affinity will also decrease. However, what about along the period? The atomic radius remains the same, right? But nuclear charge is going to be increasing. But screening effect also will remain the same, because what's happening is that the electrons are being added to the same energy level. Therefore, that along the period, the tendency to attract electron will increase. And what will this cause? The EA, or the electron affinity, to increase, and therefore it will become more and more exothermic as it goes along the period. Okay, now all these concepts put to the side, let's take an example. The first electron affinities of group 7 elements are given in the table below. Group 7, we are going down, isn't it? Fluorine, chlorine, bromine, and iodine. What is meant by the term electron affinity? So you can pause the video and try to answer this question. After that we can resume. Okay, I hope you have given a try. Now, what is electron affinity? This is the enthalpy change that occurs when one gaseous atom gains or or gaseous ion gains one electron to form one uni to form one negatively charged gaseous ion. Now explain the trend in the electron affinity trend. This is telling you what are you seeing first of all. Yeah, in explanation first, what are you seeing? I'm seeing that the first electron affinity, basically the negatives, like it's becoming less exothermic, right, down the group. So first electron affinity, this is part 1. Let me choose a better color for part 2. Red. Disaster explanation, right? Electron affinity. This is the first electron affinity. Decreases from fluorine to iodine. Why? These are the factors which we discussed. So from fluorine to iodine, what's happening? Both nuclear charge and scattering effect are increasing, right? That is true because from fluorine to iodine, the atomic number is increasing, right? Therefore, nuclear charge is also going to be increasing. Screening effect is going to be increasing because we are adding electrons, and also we are adding electrons in a different energy level. We are going to be adding electron energy levels also as we go from fluorine to iodine. Therefore, screening effect will also increase. However, screening effect increase in screening effect outweighs the nuclear charge, right? Because now we are adding electrons to the outer energy level, and this will cause more repulsion of the electrons than attraction. So the effective nuclear charge will what? Decrease. And hence, what's going to happen? Hence, the atomic radius will also what? Increases, and therefore the tendency to attract electron also decreases, and that's why first electron affinity is decreasing, as we have seen from the question. Now, Roman numeral 3. The first and second electron affinity values of oxygen atom are -121 and positive 744 kilojoules per mole respectively. So first is exothermic, second is endothermic. Explain why second electron affinity is endothermic. This is exactly the thing. So when the atom has first gained the electron, okay, in the first electron affinity, now the second electron affinity, when we want to add second electron, what's going to happen is that the incoming electron faces a greater repulsion from the electrons present in the atom. Hence, screening effect outweighs what? The nuclear charge, and hence what's going to happen is that the effective nuclear charge will be effective, hence the effective nuclear charge will decrease. Now what will happen? The incoming electron, therefore the energy must be supplied, right? Therefore energy must be supplied. Energy must be supplied. Must be supplied to overcome the repulsion. And that's why it's endothermic. Okay, so this was electron affinity. Thank you.